Thank you for downloading this podcast on 702.co.za or capetalk.co.za. The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Rudy Clappy.
26 minutes before 10, you with me, CBS Makaza until noon today. And next up, the Naked Scientist is standing by to answer all of your questions. So why don't you start dialing in? If you're in Joburg, you can do so on 011 883 0702. And of course in Cape Town, 021 446 0567. Let's see whether Chris has managed to get through his cup of tea, being all English and stuff. Hello, Chris.
Good morning. I'm drinking it now, actually.
Well, I'm sure you can multitask with the amazing brain that you have. Chris, let's start while some callers are calling in with a really fabulous article that apparently confirms that women are born to flirt.
Well, allegedly. I was just looking at this. It's in the Journal of Personality and Social Psychology Bulletin. It's by researchers at the University of Berkeley, a lady called Laura Kay. And quoting from this piece of research, just get it here. I mean, what they say about it is they say, to determine whether women who flirt are more effective in negotiating than men who flirt, the researchers asked 100 participants to evaluate to what extent they use their social charm in negotiation on a 1 to 7 scale. So in other words, the partners first rank their partner's abilities. And then they say, earlier that week, the participants evaluated their partner's negotiating effectiveness. Women who said they used more social charm were rated more effective by their partners, but men who said they used more social charm were not regarded as more effective. They then give them a little task, a scenario, where a woman bowls up to the person and says, "Hi, I want to flog a car, and the price is going to be X amount." And she does it all seriously. And then they have a second scenario where the same woman bowls up to someone and says, "Want to sell you a car," and instead of it being all serious, it's sort of a bit flirtatious, a little touch on the arm and a wink of an eye. And then they ask the people, how do you take to this person's selling technique? If it was a woman that the woman, Sue, the notional woman, was selling the car to, then they said, "I didn't like it." If it was a bloke, then they knocked $100 off the price. So, in other words, men come over as lechy if they try and be charming, and women come over as a little bit playful and worth negotiating with if they flirt a little tiny bit.
That's fascinating. I'm not sure
it's not a fair world.
Yeah, I'm also not sure whether it settles the nature-nurture debate or whether there's almost something mimetic about the way we respond to women flirting. Let's take our first question from Johan.
Hello, how are you?
Good, Johan, go ahead.
Great. Yeah, I've heard somewhere that atoms are able to change the nature. For instance, in the core of the sun, where hydrogen changes to helium and stuff like that. Is that true, and how does it work?
Hello, Johan. I wonder if what you're thinking about is the whole concept of nuclear fusion, because simple atoms like hydrogen are the most abundant in the universe, and when the Big Bang created the universe about 13.5 billion years ago or so, then the vast majority of the result of that Big Bang, eventually after a little while when things cooled down enough, was hydrogen. And now, of course, we have enormous numbers of different elements all around us. We're made of many of them. So where do they all come from? And the answer is that in big bodies like stars, which have enormous amounts of mass and therefore a lot of gravity and very high temperature, they're burning hydrogen by squeezing lots of hydrogen atoms together. In fact, 4 hydrogen atoms get squeezed together and they make 1 atom of helium, and then they give out some energy. We benefit from the energy, and the helium then accumulates in the star, and then as the star ages, it can then turn the helium into other things. Now, this is a process called nucleosynthesis, and you can start making bigger and bigger atoms by squeezing smaller and smaller ones together to make something bigger. And so stars are effectively the uteruses of the universe. They are creating all of the elements that we see in the universe, apart from the hydrogen, a little bit of helium, a little bit of lithium that was there to start with. And I wonder if that's what you're thinking about when you're saying you're changing atoms from one thing into another. Another possibility could be radioactive decay, which is when you make certain types of atoms, some of them have a nucleus which contains a certain number of protons and a certain number of neutrons, which is not a stable configuration. And that nucleus falls apart radioactively, and it spits out some energy energy and some other particles, and it turns into two what are called daughter nuclei, which are effectively smaller, and if you were to add the masses of the two together and the extra bits that have been given off, you'd have the original mass of the starting thing. So you basically break a big nucleus and turn it into some smaller ones. So that's another radioactive process that could lead to one atom type or species changing into another.
Good stuff. Let's go to Santon. Hello, Albert.
Hi. I just want to, recently that Austrian that broke the sound barrier jumping from a balloon. My schoolboy arithmetic tells me that you can only fall at 32 feet per second to a maximum of 120 miles per hour. How did he get to over 700 miles per hour?
Well, he actually managed about 839 kilometers an hour at miles an hour at peak. And the reason for this is that when he fell out of his capsule, he was at 39,000 meters. So 39 kilometers above the Earth's surface, almost on the edge of space. And the atmosphere there is extremely thin. It's totally rarefied. And so he would be accelerating at 9.8 meters per second every second. That's the pull of gravity on him. And there would be virtually nothing to slow him down to start with. So he would feel very little resistance to his fall. When we're normally moving through the air is pushing back on us quite hard, which is what retards or impedes the flight of an aeroplane, for example, which is why you have to have the engines on the aeroplane, because you're pushing air out of the way, and that takes you giving up some energy to give energy in the form of disturbance to the air molecules. He would not have faced that resistance very high up there because there was almost no air. As he fell towards Earth, he would have moved into more and more dense air as time went on, which means he would have then been having to push more air molecules out of the way, and that would have retarded his fall. So he would have slowed down. So he would have accelerated very rapidly up to a maximum velocity and then begun to slow down again even before he opened his parachute because of the resistance of the air.
19 minutes before 10. If you've just tuned in, yes, you are listening to the familiar voice of the Naked Scientist, taking all the questions you have on 011 883 0702 here in Johannesburg. And of course in Cape Town, you can get through on the number 021 446 0567. Speaking of Cape Town, let's go there and speak to Annie.
Hi, my question is, what is a black hole and how did it get there?
Hello, Annie.
Hi.
Well, we don't really know what black holes are apart from theoretically, because we couldn't go into one. What they clearly are is something which is enormously heavy. They have enormous amounts of mass, and we know that they can be produced when very massive objects like stars collapse. And the reason they're black is because they are so heavy that even light cannot escape from them. So I'll just qualify that a little bit. Although light isn't affected by gravity, the space that it's travelling through is. And so if you have a massive black hole, which is a huge amount of mass, then you will distort or deform the fabric of space, and effectively you make a bend in it, so the light goes around the bend. And if you've got a black hole in the path of the light ends up going in such a tight bend it goes in, not out, so we never see it. So a black hole is basically a very massive gravitationally active object. They range in size from tiny ones to enormous ones, which you see in the centre of galaxies. They're called supermassive black holes, and at the moment we don't actually know much more about them apart from what we can infer by the way that they interact with other objects, so stars that are in orbit around them, the way galaxies evolve, and the way that things fall into them. Because one of the ways we can probe a black hole is that when a star falls into it, which does happen periodically, then the star is ripped to pieces by the gravity on its way in, and this causes because the star material is getting squeezed very hard, it produces enormous amounts of energy. And in the same way as if I heated up a light bulb and it glows and I see light, when you heat up a thing falling into, or matter falling into a black hole, the intense squeezing of the gravity on that object makes it give out radiation, but not in the visible light, in the X-ray regime. So we see these X-ray emissions. This is called Hawking radiation, and we can see that, and it gives us some clues about what the structure of a black hole is. So basically, most of them are where massive stars have fallen apart or blown up.
Good stuff, Vivian. Thanks for holding on. What's your burning questions that you have?
Certainly. Good morning, Chris. An immense knowledge you have, which is so generously and subsequently imparted to us all. My question is actually a two-pronged one, as it were. It seems to me that there seems to be a certain preponderance for males or females to dominate in certain family lines. Now, there was a gynecologist from Canada called Dr. Shettles in 1952-ish, who said that when a woman's at estrus, she's in an alkyne medium, and therefore that favors the androsperm, which is the male sperm. I want to know that if this is true, whether it is acid or whatever it is dependent, and whether, if one eats a certain diet which isn't sort of high in acid, now that's cutting off the dairies and the meat, one could create an alkaline medium. So I want to know, A, is this true? And B, why is this dominant? Whereas, I know somebody has said, I've got girls, my husband went on to have 2 children by 2 different women, and they're both boys, whereas our family are flooded with females. So that's my question. Is it a family phenomenon, or is there some sort of chemical reason for it?
It's a lovely question, and thank you for thinking of that one. To my knowledge, there is no evidence that we can shift the balance of probability in anything other than a trivial way. Let me qualify that. So we have sex determination occurring actually down to the men. So women just produce eggs, and those eggs all carry an X chromosome. Sperm, on the other hand, because men are XY, sperm could contain an X or a Y, and therefore whether or not the woman has a boy or a girl is entirely down to, in the first instance, what's conceived is down to what sperm meets with the woman's X-bearing egg. Because if an X sperm meets an X egg, then you get an XX, and that's going to be a girl. If you have a Y sperm going into an X egg, you get XY, and that's going to be a boy. Now, interestingly, slightly more boys are conceived than girls initially. In other words, if you totted up the number of embryos that get successfully fertilized and turn into an embryo, then there are slightly more boys than girls. And one suggestion is that this is because the Y chromosome is slightly lighter than the X chromosome. X is a bigger, bulkier chromosome. Therefore, Y-bearing sperm may be slightly lighter than X-bearing sperm, and therefore may move slightly faster in the genital tract and make the journey to the egg slightly faster. And so there's a possibility that the X's will get there, the Y's will get there first. But this is tempered by the fact that if you then look by the time of birth, equal numbers of boy and girl babies are born. So it would appear that that male embryos have a higher mortality rate than female embryos. So this balances out. And then through lifetime, you see actually a higher attrition of boys and a preponderance of girls, probably because of risk-taking behaviour on the part of boys. And then in older age, again, you see a dominant female population because women tend to have greater longevity than males. But on the whole thing does tend to balance quite evenly, and we see about the same numbers of boys and girls. And in terms of whether you can influence that, it doesn't look like you easily can, to my knowledge. And if I'm wrong, please do tell me somebody, but to my knowledge, we don't know of any ways that you can naturally and safely, without involving artificial techniques, change whether you're going to get boys or girls.
13 minutes before 10, I am speaking to Chris Smith, the Naked Scientist, and we're taking your questions for him on 011 883 0702 and in Cape Town 021 446 0567. If you're on Twitter, you can also tweet me a question. I'll read it from there at Eusebius. Any questions you might have, or drop us an SMS from 31702 31567. Here's one from the SMS line for you, Chris. Dorothy wants to know, what is the physical reaction in the body when one suffers from jet lag after a long flight?
Okay, well, first of all, why do we get jet lag? And this is because you have in your brain a special structure called the suprachiasmatic nucleus, or SCN. This is a cluster of maybe 20,000 nerve cells in a part of the brain which is known as the hypothalamus. And these nerve cells have a genetic clock running in them. They have a sequence of genes where gene 1 turns on gene 2 turns on gene 3 and turns off gene 4, effectively. I'm simplifying slightly. But this works like a genetic domino effect. And to complete the cycle of all these genes takes about 24 hours. And what this has the effect of doing is changing the activity of those nerve cells so they become more or less active, and they're connected to all of the other bits of the nervous system, which changes your level of wakefulness. It changes when you feel hungry, it changes when you feel hot, when you feel cold, when you want to go to bed, when you want to wake up. And it also changes the level of key hormones in the blood, including a hormone called cortisol, which is released from your pituitary gland. This goes round in the blood, visiting pretty much every cell in the body, and that signal from the cortisol is then used to set the clocks, which are also running using the same genes in every cell in the body. So effectively, every cell in your body is keeping time, one way or another. Now, if you look at how that clock is set, it's because your eyes contain a special photoreceptor, a light-sensitive cell in the retina, and when you go out on a bright day, blue light at about 580 nanometers wavelength hits those cells, stimulates them, and they then trigger this master clock in your brain, setting it, so that you know when the morning is and you know when it's getting dark. And so then every other clock in the body, using the cortisol signal, is kept in sync with that master clock. If you then jump on an aeroplane and you change lots of time zones, now your body's physiology, when it's feeling tired, when it's active, when you're gearing up your metabolism to burn lots of energy and make you active, when you're feeling hungry and so on, those behaviours are now completely out of sync with what is going on in the world. It's either nighttime or daytime when it shouldn't be. And that disparity, when your body is in a state of readiness to do something when it shouldn't be, and it's in a state of slumber when you should be doing things, is the sensation of jet lag. And to reset this, you need that light coming in from the outside world into the eye, resetting the master clock, which then syncs up all of the body clocks again, and then you feel better. And it takes about 1 day per time zone crossed before your physiology and your biochemistry is back to normal. So if you zip across the Atlantic and you go to America, then that 5 to 10 hour flight will actually take a week for you to recover from when you're there, and then you come back and you're halfway to recovering and you've got to start recovering again. So it's nasty stuff, and people who disturb their body clock have a higher risk of various diseases. So shift workers, people who stay up all night because they have to be at work and things like that, they have higher rates of heart disease and stroke in men, I think also in women. Women, and particularly studies have shown that women doing nursing shifts, for example, have higher rates of breast cancer if they have this disturbed body clock rhythm through their working life. So it's very important to us that we actually get good sleep at the time when we've evolved to get it.
Good stuff. Hello, John.
Hi. My question is as follows. My schoolboy physics tells me that when an electrical conductor moves in a magnetic field, an electrical potential difference is created across the conductor. If we look on this on a global scale, there's an ocean current, for example, that flows east to west across the Atlantic Ocean, and it flows within the Earth's magnetic field. Does this set up a potential difference? And if yes, is there any way that one could harvest that electricity?
So your intriguing idea is that because we've got water moving across the Earth's surface and the Earth has a magnetic field, that in some way could be used? Well,
particularly because it's salt water being a conductor and a moving conductor.
The problem is that it's a very good conductor, so if there was any charge differential, if you did manage to push some charges in one direction, then they could very easily leak that energy all over the place, couldn't they? How would you harness? How would you harness the energy in one place?
Well, I was thinking mostly that where the currents are moving fastest, there would be a propensity to set up a potential difference between one end and the other. But as I said, it's really schoolboy physics.
Well, it's really tricky because people made a sort of bit of a gaffe with this when they first started trying to move electricity around, because England and France said, we'll share some electricity, and they decided to put this big cable under the channel, and if you send DC, direct current, through the cable, then you have a nice signal arriving at the other end. But DC is less useful. If you send AC current under the ocean, actually nothing comes out at the other end of the cable, despite you putting in enormous amounts of energy. And the reason is that the alternation causes the charged particles in the water around the cable to feel the changing electric and therefore magnetic field, and they all dance around, and all of the energy in the cable is dissipated and nothing comes out at the other end. So you'd have to think quite carefully about how you were going to make your generator work. And also, of course, the Earth is turning, and that means that the magnetic field is turning with the Earth. The Earth isn't turning inside a magnetic field. So how you'd actually get the water to feel, or whatever your conductor was to feel, a changing changing magnetic field, I'm not sure that's so easy to do.
Speaking of salt, Mary wants to know on the SMS line, Chris, oceans cover perhaps some 70% of the Earth's surface. How do they come to be so extremely salty, yet inland lakes are mostly freshwater?
Okay, well, what's probably what we believe to be the reason for this is that it's because of the precipitation cycle. So the sun shines on the sea and puts energy into the water. The energy given to the water causes water molecules to break the bonds holding water together so that you get water vapour, H2O, and that will evaporate from the sea. It's much harder for salty particles like sodium and chloride ions, because they're charged. It's much harder for them to evaporate, so they're left behind. So what goes up into the atmosphere is clean water, and this condenses to form clouds. The clouds then eventually rain the rain down over the land, and that's falling as fresh water, and it will collect into rivers and streams and lakes as fresh water. But as it percolates through the ground, it will dissolve very tiny amounts of salts and other minerals from the soil and from the ground as it comes into the lakes and streams. These then run down into the sea, returning the water back from whence it came, carrying that very low concentration of salts with it. And that means that over millions and millions of years, slowly tiny amounts of salt are added progressively to the sea, where they never leave again, but only fresh water goes back out. And so over millions of years, the sea has accumulated minerals to make it salty, and we think it's at about the maximum saltiness now, because if you keep adding more minerals to it, then this provokes side reactions or chemical reactions to kick in, which sequester the excess and turn it into locked away solid forms in deposits on the sea floor. So that's why the sea is now in a sort of steady equilibrium level of saltiness.
Okay, that's all we have time for. Chris, it's great hearing from you as always. So have a wonderful weekend.
Thank you. Thanks, everybody. See you soon.
First 3 months while they switch our account.
They're not?
No. FNB switched our beneficiaries, salaries, recipients, and most importantly, they matched our current credit facility. So you can hire a professional to do the pool.
Fine. Well, I'm sorry, dear. No one's perfect, you know.
I know, dear. I married you.
Get more with FNB Business Banking. The Get More, Do More